Good evening and welcome to tonight's webinar with Classpad.net, where we will be discussing proportional reasoning, direct versus indirect relationships. My name is Amy Chow, and for the sake of webinar quality, we will keep everyone muted and all videos turned off. If you do have a question, please type it in the chat panel, and I will respond back or ask the presenter to respond to the group. Tonight's presenter is Dr. Karen Greenhouse, and I will let her introduce herself in a little bit. As like I said, my name is Amy Chow. I'm the National and Training Product Manager at Casio. I'm working mostly to coordinate workshops for schools, districts, and conferences, and working closely with our development team on calculator updates and improvements. And now I'm going to turn it over to Karen.
Well, hello, everybody. It's good to see you again. We've had a little bit of a break there, and we are back. And I'm Karen. So I am a consultant with Casio and also a math educator for over 30 years. And I am going to be sharing some Classpad.net. So I will talk about what that is if you've not joined us before in a webinar, just to give a brief overview and kind of set the stage for what we're doing in our series. So I'm going to actually steal control here and share my screen, hopefully. And can you see it, Amy?
Not yet. I think I still have control.
Well, that's because I didn't hit share. There we go. Now can you see it? Yay.
Now I can see it.
That is awesome. All right. So one thing I want to talk about. So we are starting our webinar series again, where we're going to be doing software. So this is Classpad.net, and we're also going to be doing some of our hardware webinars. And that's with the calculators. And then we also have our webinars with Todos, which Amy will talk about at the end of this. But the goal for all these webinars is we're having an overarching theme of remote learning and how to use some of the tools that we have to support distance learning, teaching, those types of things. So all of our webinars are going to sort of have that focus, and we're going to be giving you tips and strategies as we're working through that. So tonight I'm working with Classpad.net. If you've not heard of it before, this is our free math software. It's dynamic software. I'm on the landing page right now. This is a free to use math software, so you can just start exploring and start calculating, doing geometry, those types of things, or you can create an account. I am going to ask you to play along tonight, and so kind of talk about why would you even want an account. If you just start exploring, you can play, but nothing you do is saved. But as you'll see tonight, one of the nice things about this activity, about this tool, is you can create activities, share them with students very quickly, and have them work along with you or work on their own on a homework, and then they save their work to their account. So creating an account, which is free, allows you to create activities and share them with your students, and also allows your students to do their homework or take an activity you've sent them and work on their own and save it and send you back their work. So I'm going to talk a little bit about that as we do things. So here's the landing page, Classpad.net. We have the links at the end, but it's pretty easy. If you don't have an account, you could hit start exploring right now, but I am actually going to send you an activity where you can just start playing. So I'm going to pop into my first activity. And the focus of tonight was direct proportion, inverse proportion, and kind of like how to help think about that using a tool that allows you to do visualization and also kind of build the understanding instead of just telling the students. So normally, so here's this activity, and I'm going to send it to you in just a minute to show you how easy it is to create something and share it with students when you're teaching remotely and have them work along with you and understand those things as they're working along. So this is an activity I created, and it has a title, and I just wanted to introduce, I kind of put up the definition that we tend to just give students. What's a direct proportion? What's an inverse proportion? So we tend to start and give them this equation. It's when you have two variables that are related by a constant. And a lot of times students are like, what does that mean? And then we start giving them graphs and examples. And what I want to do is say that you really should be giving them a little bit more visualization so that they build the understanding of what this is. So what I'm going to do right now is send you this activity, and we're going to work through together if you want. You can just watch, but if you want to work along with me, I want to show you how easy this tool is to use with students in a virtual learning environment. So I'm sitting here and I have created this activity. I have an account which allows me to create the activity and save it. So I have this activity and I created a share button. So every activity you create in ClassPad allows you to give it a URL link or public share. The difference between these two right here is URL means I only give it out to people I want to give it out to. So say my students. And public means I create a URL and anyone who has Classpad.net can find my activity. So if you've ever used any other type of tool, like a GeoGebra, for example, those public activities that you can find, we can do the same thing here in ClassPad. But right now, if I'm working with my students, I usually just do a URL share. So I use this with my Drexel University students. So I create activities and just share it on my Blackboard. So you could do the same with your own students. You could just put the URL in your Google Classroom and they just click on it and open it. I'm going to copy the URL for this activity and put it in the chat right now, which should... So hopefully you all are going to see that. And all you have to do, so let's say this is what you're doing with your students, is click on that and it's going to open a page on your computer that looks exactly like mine. And so I want you to think of this as I have the master copy and you all now have your worksheet or your student copy. So whatever you do on yours is not going to impact what happens to mine because you have your own version. If you have a Classpad.net account, which I'm not asking you to do right now, but something to think about for after, if you have a Classpad.net account, this activity you can then save directly to your own account and keep it forever and then change it and modify it. So that's how easy it is to share these activities. So hopefully everyone, if you're going to play along, you've opened it up. So what I want to talk about is how can you help students understand this definition of direct and inverse proportions by providing some visuals. And so I'm going to scroll down. So this is a Classpad.net paper, and you have unlimited scrolls. So it goes on vertically, and you'll see I have a lot of things on this paper, which I will talk about as we get to them. But the one thing I love about this tool, so it's my new favorite go-to tool, is that I can do lots of math. I can do, and I'm just going to click on a blank spot here. I can do calculations. I can do graphing. I can do geometry, which we're about to do in a minute. I can do data collection and statistical plots and statistical analysis. I can do sequences, financial calculations. So these are all templates, and I can do text. So this blue section here is an example of text, and we're going to be coming back to that. But if I scroll down, so if you're working with me, just kind of scroll so you can see this next section. This is a geometry example. If I click on this sticky here, and we call them stickies because if you want to think about it at like a Post-it note is sort of how I think about it. Each one of the possible things you can do creates its own little sticky that you can then move and manipulate and stick where you want it to be on the paper. So I kind of have organized my paper the way that I want it to look by moving my stickies. So here's this geometry sticky. This is a full geometry software. So you have all your geometry tools down here. You can do measurements and constructions and do the properties. So there's everything you think you can do with the geometry software. This is all available here in ClassPad. But what I have created ahead of time is two objects, and I'm trying to connect back to this definition here. And we're going to talk about direct proportion first. So I've created two objects, two quadrilaterals, if you think about it. One I've identified as X and one I've identified as Y. And I'm telling students, well, this is an example of two variables, two objects that have that are directly proportional. So that means that Y is connected to X by a constant. So what does that mean? Let's explore this. So I've got up here, Y is equal to K times X. So here's X. So this Y quadrilateral is some number times X. And if you look over here, I've created a slider. And so right now it's telling me that K, the constant, is 2. So let's just look at that. What might that mean? So if you want to just answer in your chat panel, this is something I like to do with my students, is first have them observe. What do you notice? What do you wonder? So what do you think it means that K, this constant, is 2? How does it look that X and Y are related? So if anyone wants to type in a little quick, thought about what a student might say if they were just looking at these pictures? I'll give you a second. If no one answers, I'll just answer myself. I know this happens. Okay, so Tom is saying that it looks like y is twice as big as x. And so maybe that's what that they're looking at. They say, well, it's 2. So this up here, if we're just connecting to the equation, 2 times x. And so that means if we're looking at size, what is twice as big? There we go, twice as big, corresponding sides. So just visually looking, it looks like obviously that y is bigger. How much bigger? Well, maybe that's what the K is telling us, that it's 2 times as big. So then I might ask the students, okay, so if I want y to be smaller than x, what might K have to become? And have them start making conjectures, and then they can test it immediately. So if I want y to be smaller than x, so right now it's larger, it's 2 times larger, it looks like, what would I have to change K to make it be smaller? So I would ask students to give me a suggestion. So maybe they throw out a number. I'm just going to make it up. Let's say they throw out half, right? Probably should have made these. Oh, it's only going by 2. So 0.6. I'm just making that up. And why is it not moving? All right, so technology is not being my friend right now. I don't know why it's not moving. That is so weird. Huh. All right, hold on. I'm going to have to recreate what I did here. Well, there goes. Okay, so bear with me. I'm going to recreate what I did. So just, you can watch me see what I described, what I created, because it does not seem to want to respond. And so I'm hoping your guys is responding, because if it's not, that's a problem. So here's how I created this. I hopefully am going to be able to recreate this. I selected my original object, X. I had a point of dilation, which I had hidden, and I went up into construct, and I constructed a dilation. And I told it the point of dilation, and then I gave it a constant, which is K, instead of giving it a specific scale. And that's where, okay, so now it does seem to be working. Let's see. There we go. I'm not quite sure what happened there. So if I go down to 0.4, let's go back to where we were talking about before. I had asked before, what would I have to do to K to make it be smaller than the original? So what number does K have to be make the Y be smaller than? So then this is just a way to explore, you know, what is that constant actually doing? Well, it is determining how large or small the new structure Y is compared to the original, right? And let me get back my measurements here. I don't know if it'll, the best laid plans, yeah. I had 2 corresponding sides measured so that you could see them. So now I'm just gonna bring them back. And we can call this Y again. So then what I would do is actually have them start comparing. So I'm going to make K be a number. Let's go back to 2. So there's K's 2. So what I'd want them to do next is start collecting data. So what does that mean? That it is a constant change, that it's a constant rate of change, the constant of proportionality, right? So then I would say, okay, now we can collect some data and see what that means, maybe graph what it is. So this is where it's really nice with Classpad.net, is you can collect data right as you're doing in geometry, for example, by simply pulling up. So I'm going to click on a blank spot here and pull up a table. And so now let's actually collect some data. What does it mean to have a constant of 2? So we're going to just look at measurements as I change just one pair of corresponding sides. Obviously, if I were working with students, maybe I'd have them have all the corresponding sides paired up, but I'm just going to compare the two sides that I've measured that are corresponding, right? So I'm going to measure record side A and record side Y. So those of you who are playing along, all I did was click over on a blank spot and pull up a data table. And now I'm just adding in some labels, and I can move my sticky where I want. So let's just move it over here. And I'm going to just record some numbers. So when the shape that I have now, side X is 4.2 and side Y is 8.4. So that's one set of data. So let's just collect some four different sets of data while K is 2. Because what I want to do is then see, what does that mean when we talk about direct proportion? What does that look like graphically? So I'm kind of seeing that it means that this shape is 2 times size, but how does that impact, say, the measurements or the relationship of the different corresponding parts of this? So let's now change our shape. And so I'm going to change my shape. And so notice I have different numbers. They still correspond. The shape still looks like it's 2 times larger, but I have different numbers. So let's collect that set of data. So I'm going to record that. And let's collect 2 more. And, if you were with students, you might want to have more than 4 sets of data points, but I am just going to, for sake of time, only collect a couple. But notice I'm not changing K because I'm trying to help them see visually what it means to have a constant that is the same. So we can change K and collect some more data at a different point. So that's what we're going to do. So let's just do one more here. There we go. That looks like a good one. And 22.1. All right. So they've visually seen that when you have 2 shapes that are directly proportional, it looks like the constant is telling you how much they are related. Like, so this is 2 times as big. What does that look like if I were to graph them? So here's where statistics comes into play. I used a data table. I collected some data. So I now want to plot this data point. So now we're going to be using the statistical capabilities of Classpad.net. So those of you who are playing along, I want to select my columns. So I'm going to select column A first and then column B. So my independent and dependent, or my X and my Y. I selected them in that order. And notice what happens when you're in statistics. You end up with a statistics soft key menu down here. And you can see all the different things that you are able to do. You can do calculations, so 1 and 2 variables. You can do regressions, which we will do in just a minute. You can do tests. So any of you who are AP statistic teachers, these are your typical tests. And intervals. So lots of different things that you can do, but I'm going right into the graphs. So when I go into graphs, I have these options available to me. I want to do a scatter plot because I want to visually see what it means to have a direct proportion if I'm graphing the points, the relationship. So when I hit scatter plot, it brings up a graph. So, and it's an ugly color. So the colors kind of go in order, and yellow is the next color. You can change the color of any shape just by clicking here on the color thing. So yellow never shows up very well, so I tend to not like to use yellow. So here is a graph. So what I want to point out here is in one document, I have done geometry, I have done statistics. I now have a graph of my statistical plot. We're going to do calculations in a little bit. So this is a really nice tool because you can kind of just really help students see all the different relationships that come. But what am I asking them to notice now? So we already saw visually with the geometry that the direct proportion, the constant kind of told us how the 2 shapes were related. Twice as big, twice as small, whatever that constant was, helped me determine the relationship between the 2 shapes or between the 2 variables. Now, if I look at it graphically, it looks like there's a constant rate of change, right? And as one is increasing, so as I increased my X, the length of my side X, my side Y increased as well. How much did it increase? Well, it must have something to do with this too. Let's check it out. And this is where now you're connecting back to this definition. X and Y vary directly. As one increases, the other increases. If they were to decrease, the other would decrease. So we could go that way as well. And it looks like that is holding true in my graphical representation. So now I can pull up a graph. So notice I was in the graph and I have some options down here. So statistics, now a graph, now I can plot a function. So now we're going to look at a function. So what function? Well, we already know we're looking for this function, right? Because we're talking about direct proportions. So if I know this is what it looks like, I can type in y equals, and we know that our k in this instance, in this example, was a 2. And let's see if that actually lines up with the data points. And that does. And so now I don't need the table anymore. I don't even need to change my shapes. I can now use my function to determine what the size of this y side would be if I am at a specific point on the x. So I can now click on my graph and identify my points. Now notice I wanted to point this out. When you click on graphs that you create, you can have points that move, but the default of ClassPad is to do it in standard notation. You can go to the settings. So anytime you see 3 dots anywhere in Classpad.net, you can change the settings of that sticky. So I can change to my decimal, which is nice. So now I have a decimal point that I can move. And so what does this point represent? Direct proportion in context of this shape. It is telling me that whatever x is, this is my y. So if I have, let's kind of move this. If this x side were 8.5, then the y is going to have a length of 17 because it's twice as big. And that's what this graph is showing me. So we're making this connection of visually what is a direct proportion using a shape, and then what does it look like when I collect points, and how are those points connected to this equation? And so I like to have students explore these types of things because then direct proportion makes a lot more sense to them, and they're making those connections, and there's lots of different representations. And I always try to start with direct proportion before you go into this inverse proportion. So I'm going to continue with this, but before I move on to the next section, kind of the next extension, is there any questions? I know I'm going kind of fast, and if any of you are new to Classpad.net, I'm happy to answer any questions if you were confused about how I did something.
Karen, I don't see any questions yet, but I just wanted to note that we will send out the updated Classpad.net paper with you guys, because the one that you sent out originally,
it's not working?
Yeah, it's not working either. So we will send out a follow-up email and include the correct paper with everything working.
Yeah, all of this. It'll be a mess. It'll be a mess. Actually, I don't need to send it. It's the same link. The link doesn't change, even though I've changed the thing. The link. So if you guys refreshed it now, you'd actually see all this work right now. So if you went back and refreshed, because basically what's happening is I'm updating mine constantly. And that's what this auto cloud save here is. When you have your own account, it auto saves. But then if you guys were to refresh yours, it would now show the updated information. So you don't actually have to change the link. All right. So the next step that I would then walk down, is, okay, so how is this related to real life? That's always a question. And direct proportion has to do, a great example is scale. So one of the nice things is then you can kind of help students start trying to figure out or determine or create their own constant of variation or scale factor by doing things like scale. I used to have my students actually go and measure their bedroom. So they first had to draw an outline of their bedroom and even put their furniture in it. And then I would have them go home and measure in inches, usually feet and inches, measure their walls. Like, what's the space between your door opening? What's the space from the corner to this? And they'd come back in with their image done and all of their measures on their drawing, on their room done. And then we would convert those into a scale drawing like this of their bedroom. And so they'd have to kind of take their measurements and figure out a scale to make it fit onto a piece of graph paper, that type of thing. And so basically this is applying direct proportion, because if I'm an architect, I start with a blueprint or a scaled model of the building that I'm drawing or the room that I'm creating, and I have to build the real thing. And so we have to determine, if my picture is here on graph paper, how do I convert these measurements to real measurements, right? So this is nice. I like to do this on geometry, and I found an image. And the nice thing about the geometry sticky and the graph sticky is you can put images right into the sticky themselves and then work on top of them. And to do that, so this is the geometry sticky. If you go to this down here, you have text that you can add, you can do an image, and you can do protractor. So all I did was click the image thing and found a picture, and it was uploaded, and it's now in my picture. I can enlarge it, if zoom in, zoom out. So that's all that I did there, was just add a picture. And then I went to my settings and I turned on the grid so that I have a graph grid behind it, so that I can really help myself figure out what my scale might be. So now what I'd want students to do is, what would be a good scale for this? So if I am, and if you're doing it on graph paper, I like the students to do it on graph paper because they can use the blocks. That makes things easier. But so here, let's say this length right here, what would it convert to in real life? So I could, get a segment tool, and I think I'm going to change the color because blue is the default, but I want something that's going to stand out a little bit more. So orange. And I could mark that, and that looks like that's 2 blocks long, right? So what would that convert to in real life? Well, maybe each block represents half a foot. So maybe the distance from this corner to the door closing is 2 blocks, or if I'm using a half foot equals, a block equals a half a foot, that's 1 foot long. So these are the kind of things they can have discussions, what makes sense, and then they can actually convert their measurements that they did back into their picture. So this is a nice way to connect direct proportion and using that scale factor, finding that constant of proportionality to help them either shrink or enlarge something. So that's where we're making that connection. And what you could then also do then is have them then also create a function where, instead of having to do each one separately, once they figure out what their scale is. So what did we say our scale is? I'm going to pull up, let's pull up a text sticky. So I'm blocking it here. I think I said 1 block equals 0.5 of a foot, right? So what is my constant? So my K is, I'm trying to figure out how I want to do this. 0.5, right? And so then I could graph it and find all my measurements that way without having to convert each one individually. I could use my graph. So my function, can anyone think of the function that I would write, my direct proportion for function that I could write for this? Anyone? Y equals, I'm thinking
0.5x.
Yeah, that's what I'm thinking. So then what does that mean? Well, it means it's basically telling them how many blocks to convert into feet. And so now they could use the graph and just take a point. And again, we need to change settings to decimal. When you do it to decimal, it actually follows along with you. If it's in standard, it's doing the constant calculation, so it's a little slower. So I like to use decimal form when I'm trying to move a point. But now they can do their conversions really quick just by using their equation. So this is where you're helping students see the advantage of having an equation. And here you could also ask, does it make sense? Where did my equation go? Does it make sense? I don't know what is going on with this. Oh, there's my equation hidden. Does it make sense that this equation is going into the negatives? And so then you could even talk about, well, do we need to limit the domain and things like that? So we probably we don't have negative distance. So we would probably want to limit the domain. And you can do that in Classpad.net simply by creating this vertical bar, which is also in the soft keyboard right there. So I could do that. And then telling that I always want to make sure that X is greater than or equal to 0, because you could, in theory, have 0 as a distance, as a length. And so then notice what that does. It only shows us the part of the graph that makes sense for the context of our situation, which in this case is distance. So we're not going to have negative distance. All right, any questions about this? Anything I've done? I know I'm going really fast, but I'm trying to get through a lot of stuff as always, and show you a lot of ClassPad features while I'm working at it, because this is such a great tool to use with students. You could have a quick little graph and have them add something to it or share their graphs. So right now I could have a student share their screen and show us what they did, those types of things, because they may all come up with a different scale, for example. So then they'd have different direct proportion equations. So let's move really quickly into inverse proportions. And so I'm using a real world example here just to try to help exemplify this, because this is a little harder to do, than direct proportion. So this is inverse. So this is a nice way to make sure students really have an understanding of what inverse means. It means opposite, and you have different types of inverses. You have additive inverses, you have multiplicative inverses. And so what does it mean in an inverse proportion? And so this situation here, have the students read it and have them maybe set up what they think this relationship means. So I might say, okay, 4 people can paint a fence in about 3 hours. What does that, can you represent that? What does that mean? If we were to do a relationship, let's say that, and let's define it down here. Let's say that Y equals your time and X equals your number of people. Can you figure out how to find K, which is our constant? And so just different things like that. So what do you know? What do you know here? You know that 4 people can paint a fence in 3 hours. So what does that mean? So how are we going to set this up? So you could ask them those types of questions. And this right here is a calculation right here. And and so then the question is, how long will it take 6 people? So right now, is this a direct relationship? Well, if you have more people, it's going to take you less time. So that is not the same. Let's go back way up here as a direct proportion, because as the people increase, my X, my time is going to go down, right? The number of hours it takes is going to go down. And so when we're thinking about this, okay, Tom's got an answer. So he has 2 hours for the answer to 6, which is correct. So how did we get there, Tom? So that is the question we're trying to ask. And so what do we know? And I'm just going to, again, use my text here. One of the nice things about the text sticky is you can do math type. So I kind of want them to create an equation. So notice when I did that, so let me just go through that again. If I click this square root of alpha button, that means math type, it creates kind of a math type box as we think about it, but that brings up my soft keyboard, which then allows me to use all the templates and do standard notation. So what do I know? I know that 3 hours, so Y is my time, is equal to whatever K is divided by however many people I have, which in this case is 4, right? So how could I solve for K? And let's do this. Well, I'm just going to do, and let's do it up in the calculator. Well, 3 times 4, right? So K is 12. So what if I don't, my question is, how long will it take 6? So now I could set up this equation with my unknown number of hours, which is y, right? So let's set up a second equation here. So now I'm looking for 6, and Tom already gave us the answer, but let's just figure out how he got it. I don't know the number of hours it's going to take, but I do know, based on solving this equation, that my constant is 12 hours for 4 people. But this time I have 6 people. And so my answer is, as Tom told us, 2. So now what is the equation that I could answer or find? So it's y equals whatever my k is, which we determined was 12 over x. So what's that look like graphically? So this is now a different type of relationship. As we can see, it's a very different looking graph. And so students are like, well, it definitely doesn't look like this graph that was direct. As x increased, y also increased. This one's very different. And let's change this to standard, not standard, decimal again, and click on here. What is happening as we increase the x coordinate? So that's this one right here. Why isn't it letting me? As we increase x, so that's the first value here, what is happening to our y? Well, it's getting smaller and smaller. So as I get bigger and bigger with x, it's getting smaller and smaller. If I decrease the x value, it is getting, the y value is getting bigger and bigger. So it's a different relationship, hence this interesting graph. What does it mean? Like, why is there nothing here? Well, now we're getting into interesting, limits. Why is there nothing at 0? Why does it look like this? So then you could ask them, does it make sense? Why can't we have a value at 0? Why can't x ever be 0? If we looked at this, we'll never get to 0. And what's the reason? So look at the context. So it's really nice to have a context. Why can't x ever be 0? Well, it doesn't make sense, right? You can't have 0 people. If you have 0 people, there's no time or hours. But also this equation, you can't have the denominator be 0. So you're making that connection as well. So lots of different ways you can do it. And then does it make sense to have this side of the graph? Can you have negative people? Maybe not. So maybe we need to limit this graph as well to only have values that are greater than or equal to 0. So again, just visual representations and context relationships help students understand a little bit better what these direct and inverse proportional relationships mean and what they look like. And so I want to just end this section real quick, and then I'm going to jump into inverse functions if we still have time. But I wanted to end this section with just an example. Another way I would do this maybe at the end or maybe at the beginning of when you're trying to help students understand the difference between inverse and direct proportional relationships is here's the graphs, right? And I've used A, and the reason I used A, let me just talk about that real quick. A is just a variable. I should have probably used K, but because I already defined K up here way before, the paper remembers and it's going to give K that same value. So I didn't use K again but it probably would. Let's see what happens if I actually change this to K. So notice it pulled in the K value that was already up here because the K, every time I use it throughout the paper. So that's a really neat feature of Classpad is your variables that you define, whether they're in sliders or they're in a calculation, are going to be the same throughout the paper, which is kind of nice. So we'll leave this, the K worked. So now notice you don't see the graphs. And the reason is you can hide graphs when you are working with graphs. You can hide them. And so you'll notice that the colors here are kind of grayed out. If I click on it, I can change whether the lines are dashed or solid, but I can also either show the graph or hide it. So I like to hide it until I'm ready to use it. So you might be maybe assessing students. What's this graph? Can you tell me what this graph's going to look like? And if K is negative, let's do that. Let's make K be a negative. What would this graph look like? Have students maybe draw a quick example or tell you in the chat panel, it's going to be a negative slope, it's going to, those types of things. So have them kind of describe it first, and then you can unhide the graph and let them see it. And it's going to show that as X is decreasing, Y is also decreasing, right? Did I say that right? So, and then you can play around. So they're looking at this visual. So then the next thing would be, gosh, it's really slow. What's this graph look like? So how's this, if same K, but how is this graph going to be different? This is an inverse proportion. So notice the difference. Inverse, this is an inverse, the opposite. We've got a reciprocal here. So then if I unhide this, I see, ooh, that is a scary looking. Make that a little bigger there. There we go. And now you can talk about the differences between the graphs and what they represent, and why is there a 0 on the direct but not in the inverse ones. So lots of different ways to help students just visually make those connections and explore. And what happens if I change K to negative? What happens if I change K to 0? Let's see what happens. So if I change it to 0, one graph, I only have one graph here because this one is just 0, right? So lots of different ways you can help students explore just by visually showing them and exploring and connecting a context and having them do something like find the scale, make a scale model of their room. My students always used to love this because they'd have a model and they could move their furniture and rearrange their rooms on their paper before they did it in real life. So that's just sort of, again, these are just ideas of how to help students kind of understand something that tends to be very confusing for them. So if there's any questions, let me know. I'm going to move into something sort of related, but kind of a step. We've got lots of steps in between, but I'm going to go into inverse functions and just talk about the same type of thing, helping students understand this proportional inverse relationships of functions this time. So if there's no questions, I'm going to move to my next one.
No questions.
Okay. All right. So this again, and let's hope it's working. I'm going to, again, I created this activity. There's not much to it right now because we're going to add to it, but I just created a URL. And so I'll just copy it if you want this. At the end, I am going to show you how to save it to your own account if you've created an account. So basically what I've done is I have graphed two functions and they are inverses of each other. And I want students to try to figure out, what does that mean to be an inverse function? So f of x is one function, g of x is the inverse of f of x. What does that mean? And notice I didn't actually give them the function. So part of what they're doing in this is trying to figure out what is the equation of each function and see if they can see that inverse relationship, right? So, and in doing so, I was demonstrating, I'm going to demonstrate for you, how to create tables, how to plot points, those types of things. So here's my two functions. And whenever you graph functions, and I'll tell you how I did this before, I actually created some functions in the calculate area first, which I'll show you at the end. I don't want to do it now because I'm going to give away the functions for you but I will show you what I did at the end. So whenever you have graphed functions, if you click on them, so I'm going to click on the original, which is the blue one, it will always pull up key points for that function. So you'll notice it's doing the y-intercept, the x-intercept, and then this intersection of the two functions, which is a really nice feature because then you can kind of start just looking based on something very simple. So before I click on these, I want to make sure, I think I'm still in standard, and I'm going to stay in standard because it's a nice way to see the relationship between inverse functions. So if I click on the points, it actually gives me the coordinates of those points. So let's click on all of them. So notice this point right here, that's the x-intercept. It's in standard form. I want to leave it that way for a very specific reason, which I'll show you in a minute. And then this right here is the intersection of my two functions. So notice that it's showing red and blue. So that's showing you that it's on both. It's a point that is on both. All right. So right now the students are saying, okay, well, this is it's a linear function. They could have a lot of things that they could describe. So these are things you could ask in the chat panel or just have kids respond to you. What do you notice about this function? What kind of function does it look like? Linear, those types of things. What do you think the constant rate is? How are we going to figure that out? Those types of things. You can take these points, and if you click on them, double click actually, and right click, you can convert them into a table. So that's a nice feature. So let's convert those to a table. So notice it creates a table for me with that point now in the table, 0, 3. And so I'm going to do that to each one of them. Right click, convert to a table. I want you to notice though that on the graph, it's showing the standard notation, but in the table, it converts that standard -3/2 to its decimal equivalent. So that's a nice connection as well. And then let's do this last one down here. So notice to get it into the table, I click the coordinates and right click to convert to the table. So this is just one way to create a table. I'll show you another way. Oh, I think I did this more than once. Oh, so notice what happened. Because this point is on both graphs, it automatically pulled in my second function, which is fine because we were going to go there anyway. So let's now click on our second function and get some key points here. And this is where I really want you to notice what happens. When I click on this point, notice this point, if we watch, corresponds to this. I have 0, 3 on the blue function, the original, but on the inverse, I have 3, 0. It looks like these points have switched. They've inverted, right? So that shows up. So 0, 3, and let's put this in our table. There we go. And it's putting all of my points on. Oh, because they're all selected. So let's. And where's my other one? I missed a point. There it is. And notice again, this is why I like standard here because it's showing the nice connection between this and the inverse. And so you can have students collect table data that way. You could click a point on here and move it and have them collect lots more data. So let's say I want 40, 37, 20 to be in my table. And then over here, let's see if things correspond correctly. My conjecture is that on the original function, I don't know why it's not letting me. There we go. It's making me crazy. I want what? 37. I was trying to get the exact reverse opposite to see that if I went to 18.5 on the blue, would I get a 40? But I'm not in standard. But you can collect data that way. You can also click on the functions themselves. Whoops. And you'll see this icon that's a table. And if you click that, it adds the table. Oh, my God. Well, I guess it's not going to add anymore. But I can now just put numbers in, 5, and it will fill them in. I can do -2. So you can create tables lots of different ways. So by collecting points yourself, right-clicking, converting them to a table, by clicking here and clicking the table icon, by adding numbers in yourself. And what you're trying to do is help students see, particularly here, that the inverse function, it looks like it's inverted the x and the y. So what does that mean? So can we figure out from our tables what the equation for f of x is? So let's try to do that. And so you'd have, I'm looking at my time, I'm running out. You would have them, this is just my next steps, you would have them try to come up with the equation for each, right? Without doing the trick that we tend to tell students about inverse, but have them from the table data, try to figure out what the actual function is and have them plot that. So let's say they have figured out that f of x is actually for every input x, I'm trying to remember what I did. multiply by, here, I'll show you. Multiply by 2 and added 3. So we're hoping they figured that out. And that should go right over that. So we have them try to figure it out. So then what is the next function? And have them try to figure it out from the table. And they're going to see that it is different, obviously, but it's the inverse. And then how are these two functions related to each other? So the inverse function is, if I am correct, oops. Now, I wrote it very specifically for a reason because I want students to see that it's the inverse. So this this multiply by 2, the inverse of that, the reciprocal is 1/2. If adding 3, I'm adding a -3. So all of these relationships. So I want them to try to figure out that when we say inverse, you're inversing all of the things that happen. And that's why it looks this way. And that's why the points look like they're reflections of each other. And what are they reflecting over? And we're going to eventually get here. I'm going really fast. So those of you who are in advanced math, you're really trying to help students see that when functions are inverses, they are reflections over the y equals 1x direct proportion relationship. So that's what you're really trying to make that connection to there. So that's where we're going with this. And I'm going to stop because I think I'm confusing myself. You can tell it's the first one in our series, but I did want to show you if you want to save anything. So one of the nice things about Classpad.net is there are hundreds of free activities. Like I just made this. They're not that awesome, but if you want to add to it or move on, there's tons of free ones out there and you can find them and save them to your own account. So creating your own account is a really advantageous thing to do because once you have your own account, and I'm just going to go to my account, basically everything you create is saved in your account. And so if you find an activity that you like, you log into your account. So the activities I've just sent you, if you want to save them when you're logged in, this button right up here. So you do have to be logged in to do this. If you're just using the free access, you can't save anything because it's the free access. It doesn't know where to go. But if you're in an account and someone sends you something, so this would be what you do with your students. If you click up here and hit duplicate, what happens is whatever you found or whatever was sent to you, there's a copy made into your own account and now it's yours and you can change it however you want. And if you want to find activities when you're in Classpad, so those of you who have not created an account, I really suggest you do because we have hundreds of activities when you are in your account. And to get into your account, you click this paper stack here and notice this will be another webinar, but you can create folders and you can organize all your activities that you find or that you create. But if you go to public papers, there are hundreds of activities. Now, these are the most recent ones that were created, but if you just go up to search and say you're searching for any papers that have to do with, I'm going to go to public papers, inverses, here's a couple. I picked a bad word, obviously, but there's 4 activities already done, ready to use that have inverse. Maybe you want linear.
Yeah, the hard part about that is
people have to remember to tag it.
Yeah, the phrases have to be tagged.
There's a lot there's a lot of things there. So there's lots of activities there. And back to our main page, if you go up to our activities here, there's hundreds that are on this page already organized for you. So if you're, in algebra and you want to do things, look, this is just, a ton of free activities already here. You click on them, they're going to open like this and you hit duplicate and save them. So there's a lot of ready to use free activities available to you already there if you're interested in exploring. So it's a great tool. It's wonderful. I use it all the time with my students in a Zoom and also offline. Not offline, but off my Zoom meeting. So they're doing things, they're opening something, working on it, saving it, and sending me their URL with their homework. So that's a way to think about this. And I'm done. I'm going to turn it back over to Amy.
All right,
Thank you for putting up with my discombobulated thinking today.
Thank you, Karen, for that. It's nice to be able to connect proportions with using different tools versus just, straight calculations or straight graphing. It's kind of neat to use the geometry, as Tom mentioned in the chat panel. As Karen mentioned, we are starting our webinar series up again. We will be hosting or doing 2 webinars a month, the first and third starting in February, Wednesdays of each month. 1 week we will have Classpad.net activities or webinars. And the other will be focused more on like our hardware technology, so like graphing calculators or even scientific calculators. So here's just a short list of some of the upcoming ones, just 4 of the upcoming. Feel free to go to Classpad.net webinars page or the Casio Education webinars page to register. We'd love to see you guys on another webinar. Additionally, we are partnering with Todos again to do a series on distance learning and access. So we have 4 webinars that have been scheduled. You'll see them here, and you'll be able to find the registration pages at the Casio Education webinars page. So make sure you save that link, or we'll make sure and use that link in the follow-up email that we send out tomorrow. So here's just a short view. And then I just wanted to thank you all for joining us tonight. And if you would like to be updated on future webinars, follow us on Facebook or Twitter or Instagram. And then this webinar has been recorded and will be uploaded to Classpad.net's YouTube page. So be on the lookout for that. And we will be sending out a follow-up email with some of the pages, the papers that Karen shared, and also provide a certificate of attendance if requested.
And there's a lot of things that I went through really quick. If you're new to Classpad, the YouTube channel has previous webinars that are specifically on how-tos, and then there's a ton of how-tos actually on that as well, like a little short snippets on like geometry and constructions and those types of things. So that's a great resource too if you're interested in exploring Classpad.net more.
Yes, absolutely. Thank you all again, and have a good night.
Yes, good night.